The technology of our age is shaped by artificial intelligence. Today we will take a brief look at the technology of the future. Artificial intelligence is defined as the ability of computer systems to imitate or perform human-like mental abilities. It focuses on the capacity of computer systems to perform mental tasks such as learning, problem-solving, language understanding, perception, visual recognition, speech recognition, and decision-making. This means that computers can perform complex tasks in a human-like manner. The main goal in this field is to provide computer systems with the ability to perform complex mental tasks such as learning, problem-solving, language understanding, perception, visual recognition, speech recognition, and decision-making. This field includes a number of basic techniques and methods. Machine learning refers to the ability of computer systems to learn from datasets. Natural language processing is a subfield that enables computers to understand and process human language. Image processing allows computers to understand and interpret visual data. Additionally, technologies such as artificial neural networks and deep learning form the basis of artificial intelligence. There are distinct differences between artificial intelligence and human intelligence. Artificial intelligence is often programmed to specialize in certain tasks, and it learns those tasks. However, it is often limited to a specific area, and its general learning ability is more limited compared to human intelligence. Humans, on the other hand, can reach a level of general intelligence and have the ability to learn in a variety of subjects. They learn from previous experiences, and can apply this learning to different contexts. While AI typically works within the context of a specific task or application, humans are capable of thinking in a broad context. People can make connections between different topics, think abstractly, and achieve a general level of intelligence. This allows people to take a broader perspective and solve complex problems. Emotional intelligence perspective. AI is often limited in emotional intelligence. AI systems can mimic human-like emotional responses, but they do not have true emotional understanding or emotional intelligence. Humans have the ability to react emotionally, and emotional intelligence includes the ability to recognize and understand emotions and respond appropriately to these emotions. Artificial intelligence were laid in the 1940s and 1950s. Mathematician and computer scientist Alan Turing's article Thinking with Computers and John McCarthy organizing a conference using the term artificial intelligence were important events of this period. In these years, symbolic logic and language processing studies on computers were initiated. In the 1960s and 1970s, the era of expert systems development began. During this period, computers began to be programmed to specialize in specific tasks. Semantic networks and knowledge representation formed the basis for computers' human-like thinking abilities. In the 1980s and 1990s, machine learning, a key component of artificial intelligence, took off. Statistical methods and learning algorithms began to provide solutions for more complex tasks by enabling computers to learn from data. Since the early 2000s, deep learning techniques and big data processing capabilities have taken artificial intelligence even further. Artificial neural networks and deep learning have achieved groundbreaking success, especially in complex tasks such as image and voice recognition. Nowadays, artificial intelligence is widely used in many industries. Artificial intelligence applications attract great attention in areas such as automotive, health, finance, education, and security. Great advances have been made in areas such as robotic systems, natural language processing applications, and autonomous vehicles. Artificial intelligence is generally divided into two main categories. Refers to artificial intelligence systems that have a general level of intelligence and can perform complex tasks in a wide range of concepts like a human. Strong artificial intelligence has the ability to reach a level of general intelligence and learn quickly and effectively in different tasks. Such artificial intelligence systems may have capabilities to think, problem solve, learn, and perform human-like mental tasks in a variety of contexts. Strong AI is different from weak AI systems. Weak artificial intelligence refers to systems that are programmed or trained to perform a specific task, and they fail to achieve the level of general intelligence. For example, a chess program may be adept at playing a particular game but not others. Strong artificial intelligence is a type of artificial intelligence that can reach the level of general intelligence and perform in different areas. Examples include large language models such as chatbots, systems that can skillfully play comprehensive and broad-based games, and technologies that can create realistic visuals. Such systems may have abilities such as understanding information in a broad context, understanding language, making connections, and abstract thinking. However, strong artificial intelligence does not necessarily have to be an exact replica of human intelligence. Such systems can develop their own unique advantages and features. For example, ChatGPT is a language model that contains 175 billion parameters, and is capable of understanding and generating a wide range of languages. It can perform impressively on many text-based tasks, translating, producing text, answering questions, and many other language-based tasks. Today, research in the field of strong artificial intelligence continues, and advances in this field may further expand the potential of artificial intelligence in the future. Weak AI, on the other hand, refers to artificial intelligence systems that are designed and programmed or trained to perform a specific task. These systems are a type of artificial intelligence that usually specializes in a specific subject and can operate in a limited context. For example, a chatbot designed for customer service may only answer certain questions and assist with certain issues. AI characters in some video games are poor examples of AI that can execute certain strategies according to certain game rules, but generally lack general-purpose learning abilities. Weak examples of AI may exhibit human-like performance on certain tasks, but they do not have the ability to think, learn, or perform a variety of tasks in a broad context outside of those tasks. Generally involves systems that work on specific algorithms or rules, are designed for a specific goal, and can use specific information to achieve that goal. Such systems are usually trained on a specific dataset and are optimized to perform a specific task as a result of this training. Machine learning, an important subfield within artificial intelligence, is a technique that enables computer systems to gain self-learning ability by using data. Machine learning is a type of artificial intelligence that is widely used and mainly plays an important role in tasks such as data analysis, pattern recognition and prediction. Voice recognition apps can recognize speech sounds using machine learning models. This is frequently seen in applications such as personal assistants or voice command systems. Image recognition allows the computer to understand images or videos using machine learning. This feature is used in many applications such as face recognition, object recognition and car license plate recognition. Financial institutions can detect fraudulent transactions using machine learning algorithms. For example, they can identify situations where a card deviates from normal spending habits. Online platforms can develop recommendation systems that provide recommendations based on users' past behavior. This can be seen in various applications such as movie, book or shopping recommendations. Machine learning can be used to develop strategy in games. Computers can learn by analyzing the game strategies of their opponents and develop more effective strategies. Machine learning can be used to recognize diseases or abnormalities from medical images. This is important in applications such as cancer screening or disease diagnosis. Deep learning is a sub-branch of artificial intelligence and aims to perform complex tasks using multi-layered artificial neural networks. Deep learning is known for its ability to learn automatically over large amounts of data and often uses deep neural networks that contain hierarchical and layered structures. Deep learning uses a neural network that usually consists of different layers. The connections between these layers are defined by weights and connections that direct the network to learn more complex patterns. These layers generally consist of three main parts: input, hidden, and output layers. Deep learning can be especially effective in big data applications as it gives the model itself the ability to learn over large datasets. Deep neural networks are designed to extract more complex patterns and perform more complex tasks than previous generations of neural networks. It is used effectively in object recognition, face recognition, and similar tasks. Let's examine an example. Voice assistants are artificial intelligence applications frequently used in daily life, such as Amazon Alexa, Google Assistant, or Apple Siri application. These assistants understand conversations and assist users with various tasks thanks to their natural language processing capabilities. Sound waves are recorded through the microphone to detect the user's voice command. Voice detection focuses on detecting when the user gives a voice command to the device. The recorded sound waves are digitized. Analog sound waves are converted into a digital format. This is because it can be processed by computers. Digital audio data is analyzed with speech recognition algorithms. At this stage, the aim is to recognize the words in the voice and convert them into a written text. Speech recognition results are fed to natural language processing algorithms. Natural language processing is used to understand the user's expressions, comply with grammatical rules, and interpret the user's requests. The outputs of natural language processing are typically directed to a knowledge base or various services. Artificial intelligence pulls and processes this information to understand and accurately respond to the user's demands. It carries out specified commands to perform an action in accordance with the user's request. These actions can range widely. Examples include creating a calendar event, providing weather information, or playing music. Feedback is provided to the user to perform the task he directs. If the user's request is not fully understood or met, the system may request more information or perform iterations to reach an accurate result. By combining these steps, voice assistants respond to users' voice commands, and their learning abilities often improve over time so they can better adapt to user needs. Artificial intelligence algorithms are constantly being developed to improve the accuracy and efficiency of voice assistants by analyzing large datasets and user interactions. Another example, facial recognition systems. Facial recognition systems are a technology used to recognize individuals based on their unique facial features. A facial recognition system must first capture an image of a person's face before it can recognize it. This image is usually captured through a camera. Image quality and resolution are important factors affecting recognition accuracy. Face detection algorithms are used to determine the facial region on the image. These algorithms include steps such as framing the face in the image and detecting the eyes, nose, and mouth. Various features are extracted from determined areas of the face. Features may include parameters such as the distance between the eyes, nose length, mouth width. These features are the data that make up a person's unique facial profile. The extracted features are combined to form a feature vector. This vector is a numerical expression that represents the person's face. The face recognition algorithm tries to recognize a person by comparing the feature vector. These algorithms can generally be of two basic types. The recognition process occurs by matching the feature vector with previously recorded facial feature vectors. The classification method, which is a learning-based approach, is used to classify a face among learned classes. The facial recognition algorithm compares a new facial feature vector with other feature vectors in the previously recorded dataset. In case of a match, the facial recognition system indicates that it recognizes the person. According to the algorithm's decision, the system reports whether a person is known or not. If recognition is successful, additional information such as the person's name or identification information may also be output. Another well-known application of artificial intelligence is autonomous cars. Autonomous vehicles are vehicles that can drive on their own and perceive the environment around them. These vehicles detect objects in their environment. react to various scenarios, and navigate safely using an array of sensors, cameras, radar, lidar, and other technologies. Autonomous vehicles use an array of sensors to collect information about their environment. These sensors include radars, lidar technologies, cameras, ultrasonic. It has sensors and GPS. Thanks to these sensors, the vehicle detects objects, roads, traffic signs, and other important elements around it. The detected data is processed by computer systems in the vehicle. This process includes steps such as transforming environmental data into meaningful information, classifying objects, calculating distances, and mapping the path. Artificial intelligence and deep learning techniques play an important role in this data processing process. Based on the processed data, the vehicle makes a series of decisions and creates a driving strategy. This strategy may involve a series of maneuvers and movements that enable the vehicle to reach the designated destination safely. For example, when it detects that the vehicle in front has stopped, the autonomous vehicle can brake or plan a lane change maneuver. The driving strategy determined in the planning phase is applied to the vehicle's movement systems. This includes systems such as steering, brakes, accelerator pedal, and gearbox. Autonomous vehicles usually perform these actions through electric motors and actuators. Autonomous vehicles constantly monitor their environment and receive feedback, updating their decisions and driving strategies throughout their journey. If a road condition changes or a new obstacle appears in the environment, the vehicle can react quickly. Autonomous vehicles include safety protocols and emergency procedures. For example, if an unexpected situation arises in the environment, for example an obstacle suddenly appears, the vehicle can safely stop or determine an alternative route in an emergency. In space missions, artificial intelligence can play a number of important roles and make space exploration, observations, and data analysis more effective and efficient. Elon Musk's company SpaceX's Starlink project is a concrete example of the use of artificial intelligence in space missions. Starlink is a network creation project to provide broadband internet access worldwide. This project aims to increase broadband internet access by placing thousands of satellites into Earth orbit. Artificial intelligence determines optimal route and communication strategies by managing thousands of satellites around the world. It constantly analyzes data to ensure fast and reliable internet access by organizing satellite routes and connections. It optimizes the frequency bands used and ensures the most efficient use of the spectrum. This improves signal quality, allowing for higher data transfer speeds. The large amount of data collected in the Starlink project is processed by artificial intelligence algorithms. It is used for data analysis, monitoring network performance, error detection, and improving customer experience. In satellite control and correction processes, artificial intelligence can automatically adjust satellite systems. This minimizes human intervention in remote control and management. The Starlink project is a concrete example of the use of artificial intelligence in space missions. This project aims to build a space-based network to increase internet access around the world, and artificial intelligence plays a key role in achieving this goal. Artificial intelligence plays an important role for autonomous spacecraft. Spacecraft can use AI-based sensing and decision-making systems to better understand their environment, maneuver, and achieve their goals. This allows spacecraft to react faster and perform complex missions. Intelligence can be used to analyze large datasets obtained from space missions. Data obtained through space telescopes and other sensors can be processed with artificial intelligence algorithms to enable the discovery of new astronomical objects, classification of celestial objects, and interpretation of events in the universe. The processes of determining spacecraft's targets and optimizing their routes can be supported by artificial intelligence. This can be used for energy saving, security, and achieving goals more effectively. Artificial intelligence can be used to optimize communication systems in space and make them more reliable. Data transmission could be improved to allow spacecraft to communicate more effectively with each other and with ground control centers. Artificial intelligence can detect harmful situations and automatically initiate debugging processes when necessary. This could improve the safety of space missions. Artificial intelligence algorithms can more effectively compress and store the large amounts of data collected by spacecraft. This could help spacecraft use limited storage capacity more efficiently. Artificial intelligence can optimize energy management during spacecraft's long-term journeys. This allows spacecraft to operate for longer periods of time by using energy resources efficiently. Artificial intelligence in the healthcare sector provides significant advantages in hospital management, patient care, diagnosis and treatment processes by offering a series of applications and innovations. Artificial intelligence plays an important role in the early detection and diagnosis of diseases by using it in radiology, pathology and other imaging fields. Image analysis and processing algorithms enable doctors to make more precise and faster diagnoses using imaging techniques such as magnetic resonance imaging, computed tomography, and X-ray. By using it in hospital management and data analysis, it can help optimize processes within the hospital. It can increase efficiency in processes such as appointment planning, resource management, and stock tracking. Artificial intelligence can accelerate the development of new drugs by using it in genetic data analysis, molecular modeling and bioinformatics applications. It also plays an important role in selecting patients in clinical trials and analyzing drug interactions. Data obtained through smart health applications and wearable devices can be analyzed with artificial intelligence algorithms to provide real-time information about the condition of patients. The financial services industry has begun to gain a number of advantages by using artificial intelligence applications. These technologies affect many areas such as data analysis, customer service, security and risk management. It optimizes risk management by using it in areas such as fraud detection, credit assessment and financial market analysis. Can create stock trading strategies by analyzing financial market data. Artificial intelligence in education is used in many areas such as adaptive learning platforms, student evaluation systems and personalized educational content. This helps teachers make data-based decisions while providing students with better aligned learning experiences. Artificial intelligence increases operational efficiency in the transportation and logistics industry by using it in issues such as route optimization, driverless vehicle technologies, cargo tracking and predictive maintenance. In this way, transportation costs are reduced and safety standards are improved. It is used in many applications in the field of security and defense, such as security cameras, cybersecurity measures and threat analysis. The ability to identify abnormal patterns by analyzing large datasets enables rapid and effective interventions. Don't forget to subscribe for brand new videos and more scientific content.